All right, example 4 from 11.1 on polynomials. Here we have a word problem where Anita Lone. Get it? Anita Lone? Never really noticed these names before. They're pretty funny. Anita Lone and her family start saving for college when she graduates from 8th grade. And at the end of each summer, they deposit money into a savings plan with an annual percentage yield of 5.8%. And Anita is planning to go to college in the fall following her graduation from high school. How much money will be in the account when she leaves for college? And if no money is added or withdrawn, with the exception of the amounts that they're putting in at the end of the summer. So here's the table, and this is a basic polynomial type of situation where we have an interest rate of 5.8%, and at the end of 8th grade, Anita is going to put the $1,200 into the account, and then that $1,200 is going to earn interest for several years until she graduates from 12th grade. So it'll earn interest for 1, 2, 3, 4 years, because after she's done with 12th grade, it'll come out, and then she'll use that to pay for college. At the end of 9th grade, this $850 will only be in the account for 1, 2, 3 years, because 3 years later she will graduate and then go to college and use this money to pay. 10th grade will be in there for 1, 2 years, 11th grade for 1 year, and then 12th grade it won't be there at all, because at the end of 12th grade, she'll take this money and then just go for college right away. So what's happening here is we have a polynomial, and we have this interest rate is the amount that the money is going to be multiplied by, or the exponent of that, to find the total amount there. So what I'm saying is this. We have 1,200 times x to the 4th power, where x represents the interest being added on to the $1,200, and that's going to be for 4 years. So we're going to take, if it was just the $1,200, we would take the 1.058 to the 4th power and multiply it by 1,200. That's our basic compound interest formula right there. This 850 is only going to be in there for 3 years. The 975 is only going to be in there for 2 years, and then the 1175 for 1 year, and the 1300 won't be in there. It won't earn any interest, because at the end of 12th grade, you're going to take that money and pay for college. So this is the general algebraic polynomial that's associated with this. The application of that would look like this. For the 1,200 times the 1.058 to the 4th, so this is what I said, and this is just kind of mapping out exactly what this looks like. So how much money will be in the account when she leaves for college? It would be the sum of all these values, and I didn't even do that, but this is the expression that we would use to find the amount in the account when she leaves for college. So it's the 1,200 times 1.058 to the 4th plus the 850 plus, notice all these x's are the same because the interest rate never changes. And then the 1,300 doesn't have that interest right there because it's not earning any interest whatsoever. So this is a kind of general polynomial form in terms of a word problem here when we have a constant percentage rate over some time in which we're saving some money.